think we are live. The people demand a snazzy shirt. Oh shit. Alright, can you people see me though? Alright, this is all very new to me. If you can see and hear me, please say something. Yeah. Let me get the comments on my phone. Bring it on, hit it. Oh, there's quite a delay. All right, but that's okay. We can work with that. Cool. All right, hello everyone, and welcome to this impromptu little Cat's hack stream that I decided to do. Yeah, and I don't really have this planned out too much. I have a few ideas on what I want to work on, but we'll see how it goes and how many issues or pull requests we can do. I hope to get at least one pull request. That may or may not happen. That's just something we'll have to see. But yeah, I'm really glad this worked out, and I see already a lot of comments floating in. Relax. I'm trying to relax. It's not. It's exciting, you know. Especially because I can't see anyone. I can only see these comments, and apparently they're like delayed by almost a minute. But yeah, this should be fun. So, without further ado, there was one thing I really wanted to check out, and that is we have the semigroup K type class in cats, and this is not showing up here. And this is, I guess I added this almost a year and a half ago, a combined K eval method. And so basically, combined K is, we can send you selfies if you want. I do want selfies. Please send me selfies. So combined K, for those that do not know, I'm just going to open up Ellis's work stuff. More work stuff. All right, this is cats. I'm just going to check out the master real quick. Oh, my computer's slow while recording. Well, that's okay. All right. Oh, we might need to have to re-import changes, but that's okay too. In the meantime, we can talk about combined K. So semigroup K is a type class. Oh, that's bad. Mer text document. Oh, it's because it's deleted. Yeah, that's fine. Never mind. Nothing went wrong just yet. So let's have a look at the semigroup K type class, for those that don't know it. So semigroup K is a type class, and it has this little type member, type constructor right here, F, and it is defined mostly by this one method called combine K. It has this neat little alias that some people like to call the tie interceptor operator or something. And basically, it says that for any A, if you give me two F of A's, I will combine them into one. And they're therefore kind of similar to the semigroup, where basically you say for two given A's, you can combine them together into one. The selfies are coming. Thank you, Jakub. I love it. Right, and this is very similar, except that the A here is kind of universally quantified. So you can, instead of saying, oh, I have a semigroup of list of integer, like in this example right here, you can just say I have a semigroup K of list, and what's inside it doesn't really matter, right? So we can combine them no matter what, no matter what's inside of that list. And yeah, so this is the combine K method. And the thing we're trying to do is to make a lazy version of this, right? So this is eager. Obviously, both of these things will be evaluated. So I should add here, of course, that if the f itself is a lazy data type, then of course both of these won't necessarily be evaluated. So for example, in the case of cat's effect, you do something like this. Hello, and then use the typewriter alias to do something else like launch nukes, which is a really weird example, but for some reason it's used a lot. A typewriter, I think, a tie. That's funny. So in this case right here, this second one will never actually launch the nukes. This is because IO is a lazy data type, and it only evaluates if it needs to. But for something like option, so let's say we have an option of 42, and then we use the typewriter to do another option of 31. In this case, both of these will be evaluated, and this is not really a big deal. But if you maybe have like some really large computation that is pure in here, you might want this to be lazy, right? And this came from a use case one of our users had. Shout out to Matt if he's here. He was trying to use a Kleisli of option T and to get that laziness for what is basically or else. So this, the semigroup K instance for option basically has or else semantics, right? So this will return option of 42, but if I had none right here, this would return 31. So basically it checks, oh, do I have something in this option? If not, return this other option. And that all works fine and good, but if you look at the signature of or else, which I'm not sure we can do here, but yeah, we can do. You can see it is a by name parameter, and that basically means that you will have laziness, and if you use combine K with these, you won't get this laziness, but we kind of want to get that back. Can this even be done without defer or referring implementations to implement? Great question. Yeah, I don't think this can be done with defer or like eval. You could hardcode eval, but I'm gonna try to go for a version with defer. And for those that don't know, you can check out defer real quick. Defer is simply a type class that defers a computation, right? And so, for example, with eval, you can say, if you give me an f of a, I won't evaluate it until I need to, right? And a number of different data types you have instances for defers, or something like IO, sync IO, Linux task, whatever. All of the effect types have it, and also eval. I don't think there is a bunch of others that have it. I know that we have instances for like function 0, which is kind of isomorphic to eval. But yeah, so that's eval. This is semigroup K, and we want to get something that that adds the laziness or the ability to defer the computation within combine K. And so I guess the easiest thing we can do is, oh, you're talking about syntax for defer. Yeah, I wonder if we do we have syntax for defer? I really don't know. But yeah, let's try out and write a combine K defer method. And for this, we will need some other type constructor. We'll name it G here. And we'll just get this defer constraint bound. The video is super choppy, is what Pedro is saying. I'm very sorry about that. Is that true for everyone? I'm not sure how I can improve that. Maybe I'll just let this be and try to improve it in my next stream. I don't know. Also, to be fair, like my screen is also kind of choppy, so yeah, we will see. All right, so we have this combined defer method where we added a type constructor G, and we also say this will work for all A's, and in essence, the rest of the signature is going to be fairly similar, except that the second parameter is going to be wrapped in this G type constructor. So here we have a G of f of A, shut down SPT. Yeah, I don't know if that would work. SPT, it's not even running here. I might shut down just a bunch of this other crap that I'm not using right now. Maybe that will help. Usually my MacBook, it got better. Okay. Usually my MacBook's pretty good, but I don't know. Alright, got a bunch of stuff here. Sorry about that. I guess I should have prepared a little better. Alright. Maybe this will help a little bit. So, given all these things, I'm streaming in 1440p. Is that too much? Should I lower the resolution? Yeah, that would be encoder. Alright, should I just try this right now? I'll just try this right now. Let's see. I guess I can. The delay is more annoying. Is there a delay between the between me saying something and you seeing something on screen, or is it just delay from me saying something and you getting to see that? I wonder. Video. I guess I got 1680, which is pretty high. But I would need to. Alright, I'm just gonna try this wheel. Yeah, this does seem to be stuck. Alright. I'm going to just stop. Alright, I think we should be back. Can you guys see me? Can you guys, does this work? Let's see. Alright, I think we're back. Are we? Yes. Cool. Alright, great. Yeah, so Twitch was better about that when you were streaming. What kind of hardware do you have, Jakub? Maybe I should try Twitch. It's also warm here in my apartment. Maybe I should turn on the AC. But anyways, so we take an f of a and a g of f of a, where g is something that can defer computations, and then we also return a g of f of a. And I think the most straightforward way here would be to just say, I guess g also needs to be, because defer doesn't give you, doesn't extend anything. So what I guess we need to do here is also add a functor constraint. Right, because we need to actually look inside that and apply combine k to both of these things. So what I think we need to do here, wait, I'm a bit confused. You'd require a defer of f Oh, that's interesting too. Yeah, I think that would work as well, but that wouldn't give us any way to do that for option, because option doesn't have a defer instance. That's an interesting. But I'm kind of want to like go do the same thing as we have in apply for map to eval, which I guess we could take a look at. Maybe we should start with this. Just do something like this, f of a and y, which is an eval of f of a. And then we get an eval of f of a back. Oh, what's this? What does this mean? Am I still streaming? Am I still live? What happened? Yeah, I'm still live. Okay, so it's just my phone that's weird. Alright. Sorry about that. Alright, so let's just have a look at the apply type class and the map to eval. Where is it? Map to eval. So here we go, right? Yeah, and this is basically kind of what we want to recreate just for combined K. And yeah, what we do inside here is basically just take this eval, map it, and then call map to under the hood. And I guess we kind of do the same thing with semigroup K and eval. So what we do right here is just say, hey, I want to map on this eval, which gives me some kind of underlying f of a, which I'm just going to call yy. It's not the greatest name. And then we'll just call combine k with x and yy. And that should do it. But now I'm thinking like, this is interesting, because if I look at this and I want to write this generically for defer, there's just, I feel like I don't even need the defer constraint here. So I'm a little bit confused as if this method even makes sense with the defer constraint. I guess we could just write it out. But I guess, right. So this is what I'm thinking about. Okay, I found the reasoning again, and the reasoning is, of course, that this will be it's not traversed, Jakub, but this will be because if you override this, for example, with option, you will need to defer that second computation. So you do need, as far as I can tell, that defer constraint. So let's just do something like as we don't have the syntax and scope, which is fine. I'll just call map on y, and then do the same thing here. Right, and this should work for now. But yeah, the interesting bit is where you override it in the instances and actually get the laziness. So let's look at this. Let's look at the Scala doc that we have here on a map to eval, because I guess it's kind of similar to what we're going to have, except for short circuiting. We kind of have, I guess it is kind of like short circuiting, right? So it's kind of the opposite of short circuiting, where it's like if something, like in this case, if you did this with option, you'd be like, oh, if the first option is none, then you don't need to evaluate the second one. And in combine K, it's like, if the first option is some, then you don't need to evaluate the second case. So it's kind of short circuiting in the same way. But it's kind of short circuiting again, but it's short circuiting on the opposite case of the first one. That's a weird way to say that, but I think it should make sense. In one of my projects, I abused the fact that any defer compliant functor has a lazy map. Is that the reason you have in mind why defer is not needed? Yeah, I guess because yeah, map is always lazy because functions aren't evaluated until they are. Yeah. All right. Anyways, so let's look at the option instances for apply and see how something like apply can, something like option could override this, right? And so basically right here, we can see that in the case of none on FA, we just short circuit right here and say, okay, this whole thing is none. And we never actually evaluate this f of b, right? This is never evaluated. And yeah, I guess this is exactly how we can do that for option as well in the combine k eval or combine k defer. So let's go first with combine k eval. I know we have combine k here somewhere. It's basically like an Uber instance which has everything. It has monad error, alternative, commutative monad, coflat map, align, and traverse. So combine k is right here. So we'll just put the combine k eval override. I guess I need to do the override. I have a. No, that's all we need. X is going to be option of a, and y is going to be an eval of option of a. And we're going to return an option of a, an eval of option of a. And I think we can kind of go with it like the same way we did it in the other thing, where we just basically pattern match on X. And in the none case, we will have to evaluate that second thing. So I guess in this case, we can just do Y, because it is already inside of that eval. But in the sum case, we do not want to evaluate Y. So what we'll do here is, so we have an A. And I guess what we can do here is just take this thing, which is an option of A. I'm going to extract it right here. We don't care what's inside here because you don't want to rewrap it. So we're just going to take eval.now. I don't know, is this in scope? Do I need to import this? It seems like it's in scope. And just put it right here. Yeah. And that's how we could define combine k eval for option. So now let's try to do the same thing with combine k defer and see if we actually need this defer constraint. So I'm not really sure if we do, which is interesting. But I don't know, maybe someone in the chat will be like, oh yeah, I could use or else there. It's a good point, Jakub. I think I like this implementation better. But yeah, it doesn't really matter either way, because then if I use or else, then I still have to wrap that whole thing in an eval, right? And I think, yeah, I like this implementation better. So, in the case of defer, we don't really. It's very interesting to me, because I don't see how we would need to defer this computation here. Because as far as I can tell, this is just the same thing, right? Instead of, I guess here we would want like we don't want to defer this computation, right? Because we want to evaluate it. So defer doesn't even give us anything here. We would need like applicative to call pure. Right, to get into G, we could do defer G dot defer, and then actually we can't even do that. So we would need applicative here, and I wonder if this even makes sense. Like, is this something we would want at all? Maybe it's just good to go with this combine K eval and leave the combine K defer for another time. So I feel like I need to think about this more, and that's going to be a very boring stream if I'm just gonna sit there and think about the problem for like 10 minutes until I fully understand the ramifications of everything. So what I'm gonna do is I'm just gonna delete this. I'm going to delete it from semigroup K as well. And just, leave it. Maybe I will think about this more and implement it in the next stream that I do. But for now, eval basically gives us the same thing, where we want to, where we get that laziness from this. So, what other instances could benefit from this combined K eval? And I guess we should probably try to compile this at some point, because I think my metals kind of broke, which is weird. Well, let's see. I'm just gonna open up SPT, let it start up for a while. Functor F map, applicative unit, a lazy for any lazy F. Yeah, that's something you can do, Arthur. That's definitely something. I guess that is pretty much equivalent to defer, right? I wonder if maybe defer should extend applicative, but I don't know. There's a lot of ramifications I haven't thought about exactly yet. But yeah. So we have combined K eval an option, and I think the most immediate thing is like either, because either is kind of the same thing as option, just instead of having the none case, you have the left case, which might have some other value. So let's find that semigroup K instance. Where is it? Here is it. All right. So we'll just override it right here. Come on, K eval. And the implementation, again, should be very similar. In case of the left, what do we want to do? If this is left, then we kind of just want to return the second thing, which makes sense. But in the right case, oh yeah, I guess I don't even need to get this out of the, I don't need to introduce a new variable here with at, because I can just reuse x. Didn't think about that on the option side. But here we just do now, which eagerly evaluates an eval instance of x. That's pretty easy. So let's go ahead and do this here too, because I think it looks cleaner, right? This is like, instead of doing this, we can just use x right here. I feel like that's pretty clean. It's a very clean implementation. So let's look at this. SPT is still going. Welcome to SPT. Oh yeah, we updated to SPT 1.3.11. I'm also running Java 11. I wonder if that's going to cause any problems. I think it wouldn't, but you never really know. All right. So you have either an option. What other semigroup K instances do we have here? I know that list has one, but it won't really benefit from the laziness, because combined K is defined as as list appending, list whatever, list concatenation, that's what it is. And that is an eager operation, so it won't really benefit from this. So if we actually override it, I don't think it would change anything, to be honest. It would just remain the exact same. So I'm going to skip list for now. I'm also going to skip set, but we could look at lazy list or stream, which are in do we have, wait, source main Scala, here in Scala 2.12 we have different instances for stream right here, and in 2.13 we have, of course, the lazy list instances. I'm gonna go with lazy list first because that just kind of makes sense to me. Oh yeah, lazy append all. I guess in this case, because it's already lazy, and lazy list doesn't even have a, so even in this case, because all of it is lazy, I wonder if this changes anything at all. Yeah, now that I think about it, it's lazy list, because here lazy list, like, if yeah, I think I was just completely mistaken on this doing anything. But yeah, we might be already done with this, but I also haven't compiled it yet, so we might be in for something. So let's just go to core JVM, which is where pretty much all the type classes and data types and instances are defined, and we'll just compile things for now, see if that works. Stuff that we had, this might take a while. In the meantime, we could look at some of the tests that do check the laziness of map to eval, because I think we do have some of those tests, like the short circuiting tests. I'm not sure where exactly I would find them though. Is there something like short circuit test, short circuit suite, sorted maps, spooky stream seeds, syntax suite? There is nothing I can see, but we can just do a search for map to eval. Let's see what happens. Oh, my computer is really slow. Wow, even the test, the search results are coming in slowly. This is very, this streaming thing is really taxing apparently. Let's see. Short circuiting tests, I saw it there, okay. So we do have them. I guess I just didn't find it earlier. Short circuiting tests for traverse filter. I guess we would have to define them for foldable, because we only really get to use it in this way. That's the same way traverse short circuits with map to eval, the same way we could do it for, I believe it's called fold K. Yeah, fold K. Fold K should short circuit if combine K eval short circuits. But that also means we would have to override fold K to use combine K eval. So this is, yeah. So we just discovered a whole new problem space, or I just discovered. Maybe this was obvious for you. In that case, like, well done. But yeah. Sip of water. All right. So let's look at this law right here, if we can. Oh, I cannot. That's annoying. Ah, I love you, metals, but I also don't like you right now. So where does this laws come from? Oh, it's short-circuiting laws. All right, so we can go in there, though. Can we not? Wow, this is really... Oh, short-circuiting laws. Laws. Okay, next time before I stream, I'll try to just do a test run to see if my computer can handle this kind of stuff. All right, traverse short circuits. Traverse does not do short circuits. Oh, this was written 6 days ago. That's cool. On the bleeding edge, folks, we have this restricted function which I've not seen before. Oh, okay. Oh, that's fascinating. Basically takes the max invocations allowed, which basically determines if something short circuits or not. That is fascinating. So what do we do here? The invocations should be max invocations +1, or the size, whichever is smaller. How does that make sense? If max invocations allow... Oh, okay, +1. Yeah, I got it. If the size is very small, then it makes sense. All right, so I guess what we want to do here is write this kind of thing for fold K. Yeah. And can we reuse this restrict function? Because we short circuit. We short circuit in a very different way. But let's just try this. Sometimes these things just come as you're typing it out. So we want a lazy fold K, short circuits. There we go. And you'll have an f of a, and we'll need an implicit f. Oh, not traverse. I'm just typing foldable of f. And I guess, yeah, we'll just use this is equal long. Basically what this is equal is, for those that don't know, we have this little bidirectional arrow, and this will be run for different kinds of f's, and it will basically just check that these two sides here are equal, and this is a data type called is equal, because the actual checking will be done by the framework that you use. So this just uses discipline, and you can basically, there are different I want to say adapters or adapter libraries that use discipline. So there's discipline Scala test, there's discipline specs 2. I believe there's discipline munit. There probably is some more, but I don't really know. I'm not 100% sure. We will see. But it doesn't really matter in this case. But yeah, so what we'll do is, I guess, something similar to this. So we should also use option here for our tests, because option, in the same way that option short circuits for traverse, should also short circuit for fold K in this case. This is exciting. Like, I'm learning new stuff about cats and how all of these things work as I go. So yeah, this is definitely exciting to me. Are we still streaming? I feel like it's weird, but I also don't really know. Don't see my live chat anymore. Yes, there is a discipline unit. Okay, Ross, thank you so much. You've at least confirmed I've been streaming for the past 1 minute. Excellent. Okay, so I'm just gonna copy a lot of this just to, you know, see what's going on. Kind of want the same thing. Just instead of something being some, we want something being none. I was pointing at the screen just now, which you probably couldn't see. I think you can only see like my face area. Alright, so so we fold K. Well, I guess, does this works for traverse or only for, I'm wondering right now, does this work for sequence? Because it should also work for sequence, right? No, it doesn't work for sequence because then you already have all of those options. So we don't want fold K, we want fold map K. Haha, that makes more sense to me. And this function, restricted function, it's going to go from an A, and so in this case what we had here is we traverse the whole thing. I'm just gonna like, that's interesting just because I guess what we would need here is the opposite of none, in this case the empty case, which would be a sum of some A. Well, we don't have an A, so I guess what we could do here, and maybe this is total bullshit, but we'll see. Let's do this, max allocations allowed, and if those are all there, then we'll just use this empty. And now we can use this F and fold map K, because option has the semigroup K. And then, as far as I can tell, the invocations dot, what is this? Where is this? This is a, oh, it's an atomic, gotcha. Yeah, that makes perfect sense. This should be the same. Just gonna copy this. Copy and paste driven development, everyone. Yeah, I feel like this should be, this feels right to me. Oh no, our compiler actually compiled things in 520 seconds, which is interesting to say the least. Yeah, but obviously none of this will work until we actually make a short-circuiting fold map K, right? And right, no, I think that makes perfect sense. So we basically run, like, let's just think about this. Say we have a list of A's and we want to run fold map K, where option is our monoid K, and we basically want to short circuit if one of the things becomes sum, right? Because as soon as we have a sum case, we no longer need to look at the rest of the list. And this is basically what we've encoded here. I hope that makes sense for everyone. I'm just learning this, like this machinery of this restricted function thing, which Gagandip Kalra, probably butchered that name, I'm very sorry, contributed to us 7 days ago. Yeah, so thanks a lot, Gagandip. Sorry if I mispronounced your name, I'm really sorry. But yeah, thanks again. And now what we should do is let's just go and have a look at list and its fold map K implementation and see if we can add some short circuiting. So we go back to core. let's just get rid of these for now. And we will look at the list instances. And we'll have to look at fold map K. Right, here's fold map. I guess fold map K, there probably isn't a fold map K, because why would we override that? Right, I'm just gonna double check that real quick so we don't have two. No, we don't. Okay, perfect. So I want to make this thing short circuit. Fold map K. Right, and this is, I feel like I've talked a lot about fold map K, but this is the actual signature you can see here. And basically, if you have a list of A's and you want to like fold that list into some kind of monoid K, G of B, then you just take all of the elements in the list, all of the A's, run the function for each of those, and then use the combine K function, or in our case, the combine K eval function, to turn all of those A's or all of those G's of B's into a single G of B, right? Right. So, and to do this, I am just going to kind of like have a look at this traverse implementation, because it does the right thing, I assume. So we're gonna write a tail recursive method here. Is it tail recursive? I wonder, it should be, but yeah. This is cool because you can right here see exactly. This is something I went into one of my recent talks, is that applicative is kind of a monoid, and monoid K is also kind of a monoid. So these things, you know, like if you look at these signatures, list of A to G of B to G of B, it's very similar to this one right here, where you have a list of A and A to G of B, and we return a G of list of B. So the only difference right here is this list, and that just happens to be because here, like if you think about it, here we go through the list, at least in the terms of option, we go through the list, and we take the first thing we find, right? The first thing that is sum, and we just keep it. And in this case, we take all of these sums, right? We accumulate them in this list, and the moment we hit a none case, we're like, ah, fuck it, this is done. Can I say fuck on the screen? This stream, I don't know. I feel like we're all adults, so if anyone's offended, sorry, I won't do it again. But yeah, so let's write this loop function. We have a list of A's, and we want to go with an eval of G of B at the end, because we only want to evaluate it at the very end. And I guess we can pattern match here. And in the case of nil, what do we do? So let's just think about this. If that list is nil, we can't really do anything, so we just return g.empty, right? And we need to wrap it in eval dot now there, because this is literally the only thing we can do, right? We don't have a single A, so we can't call this function, and we have to return a g of b somehow. So this one's fairly straightforward. And now let's see what happens if we do pattern match on the head and the tail. So basically, we will have to call this combine k eval, and the first thing we have right here is f of the head, right? Because that's how we get a g of b. And basically, we only want to evaluate the rest if I guess this will just take care of it, right? So I guess what we do here is basically just say defer the next step, which is the tail, and I think that should do it. Like, I think this is the whole implementation. Let's see what happens if I compile this. Oh yeah, of course we only define this loop, and then we just call this loop on this f of a, and then yeah, and then we just call value. I believe that should be it. We'll see at some point if this did work or didn't. This is a long compile. I think next time I'll just turn on the AC. I think this is partially my computer just not being up to par. Maybe I need to turn the resolution down even more. I mean, we're streaming in like Super HD, or not Super HD, but like HD 16:10, which is probably quite taxing, and then it also has to process the webcam and the audio. So I guess it's a lot of load. But yeah, this compiled. I'm really glad. First try, I guess, in a sense. And if I think about it, like each of these steps, like they all make sense to me. And as far as I can tell, like this all, like if we call this one right here, right, with option, and this thing is a sum. If we look at the instance right here again, in the case of the sum, we never evaluate this thing, so it never goes into this loop, and basically it just short circuits right there. So I think we implemented laziness. If you ever wanted to call full map k on on what's it called, on list with option, and wanted it to be lazy, now it is, or now it will be once this whole thing gets released, which might be a while, but yeah. Okay, so I guess the next thing we should do here is do the same thing for something like lazy list, or I guess there's a lot of things like set, sorted set, vector. Yeah. I don't know. Let's just go with vector, because I would like to see the traverse implementation of vector. Like, how does it work? Does it use recursion? Does it use something fancy? Oh, that's interesting. But yeah, this is probably very similar to what we'll have to do. So let's just try it. This is a final override. Why is this final? I don't know. I'm just not gonna make it final. Things like these, you know, like I think this is a really good. It's probably really good for people to see that aren't much of open source contributors, but I've been a CATS maintainer for almost 3 years now, and like sometimes I really just don't have a clue why things work the way they do. I mean, it's a large project, and I also maintain a bunch of others. But yeah, basically, a lot of the time, you'll just like come up with these things. I was like, oh yeah, I guess this is final, but I'm not sure why. Because especially if I haven't touched this code in like, I don't know, I probably haven't touched this code in at least 6 months. And you know, a lot of the times, the stuff in CATS is super stable, so you don't really need to touch it a lot. But yeah, I hope this is insightful, and I hope people get something out of it. We have 18 people watching. That's pretty cool. Damn, I didn't think a lot of people would be interested in this, but yeah. So what we want to override is fold map k. And I'm just gonna follow this traverse template because I assume that it is something that is already optimized, or is already, at least at the very least, is something that does the short circuiting right and plays to the strengths of vector. And I guess what we do here is we just kind of go through it through an integer index. So basically we just loop through it like that, which is interesting. It's something I haven't done in a really long time. Use an integer as an index to traverse a data structure. So this is fun. And so if it is smaller than the length, which means we keep going, we will use this combine k eval, and we will do it for f of a get. Oh, I guess get is just apply. So just get the element at I, which we'll start with at 0. And then we'll call this f, right? So fa apply I, wow, talking in symbols. That is going to give me an a, and with that f, we turn it into a g of b. It's going to be the first argument. And then we're just going to defer the loop with, oh man, this is really neat. I don't even need to think a lot about this. I plus 1, right, because we want the next element. And if we're done, if I is the length of the list, then we will just eval now empty at the very end. G.empty. And then of course we need to I'm missing a parent. Alright. Yeah, and at the very end I'll just call loop with 0 dot value. What is this about though? Gmap. Oh, okay, because it uses a list. That's why he needs to. Okay, that was easy. If it compiles, it seems very reasonable to me that it would compile. But a lot of the time, I have something very reasonable, and it turns out to just not compile at all. All right, it's compiling. And it works. All right. So I could go on and just do like set, sorted set, whatever. But let's actually verify this by using these short-circuiting laws and actually implementing them. So full map k short circuits. I wonder what other laws there are here. So, oh, and then it doesn't short circuit for some non-short circuiting applicative. That's interesting. Oh, so basically he just defines something that doesn't short circuit. Okay, that's cool. Yeah. So I guess we can kind of do the same thing for monoid k. Non-short circuiting monoid k. K of option, and I guess this is just like use def empty. Is monoid k in scope? It is not. So let's just take these. Yeah, I'm manually putting these in the same brackets. Sorry if that offends anyone. I don't think it does. So monoid k is in scope. Perfect. And now this should, yeah, there we go. And so this is just going to be none. And the combined k is going to be x or else y. And that, this doesn't short circuit, even though or else is lazy, just because y is called right here, in case someone was wondering about that. So now we have a non-short circuiting monoid K, and we can kind of duplicate this thing. Doesn't short circuit. What did you call this? Won't for sure. Won't. Okay. Fold map K won't short circuit without the S. And here we will manually pass that monoid K. Oh, so the foldable, I guess we'll just leave it at that. Foldable F. And we will I guess this is just F. And this is just the non-short circuiting monoid K, right? I think that makes sense. Oh yeah, and of course in this case we will want to be, we'll say this won't short circuit, and therefore we'll invocate this function exactly the same time, exactly the same amount of times that this f of a has elements. Okay. Yeah, right? Yeah. And here we have the same thing with traverse filter, filter A. We don't really care about these too much. I think that should be it. So now, in case you're not familiar with the laws structure of cats, basically for every type class we have a laws file, and then also a test file that basically integrates that with discipline. So here somewhere we have short circuit tests. There we go, short circuiting tests. And yeah, this is the file we saw earlier. But basically we'll just do the same thing here for fold map. Or I guess just for foldable, right? I guess we kind of, I'm not sure. Since traverse filter and traverse are both type class names as well as the actual function names, I'm not sure if this refers to the type class or the function, so I'll just use the type class. So we will need some kind of array, just has to have an arbitrary, and we will need an instance of foldable. We probably also need an arbitrary of f of a. Was there ever an arbitrary k, by the way? Does anyone remember that? I feel like that was planned at some point, or maybe someone just came up with it. And I guess we also need to have an EQ for long. Do we need to pass this though? I guess we couldn't we just use the one by cats? I don't know. We'll just pass it along, since that's what the other things do, and makes sense to me. New default rule set. We will call this fold map K short circuiting. The parent is going to be non-existent. This is like because our type class hierarchy forms a tree. Is it a tree? It's probably more like some kind of graph, now that I think about it. But it forms, yeah, but basically, if you want to test, for example, the monad laws, you'll also want to be testing the applicative laws and the functor laws. And this is why we have this parent thing, in case you were wondering. And here we only have these two cases where fold map K short circuits if monoid K of G dot combine K eval shorts. And I'll just say for all laws dot fold map K short circuits of A, and this will automatically, right, since for all expects a function from some kind of A to something, to an is equal of something, we just use these underscore to say, to partially apply this. Well, it's not even partial apply, I guess it's currying. If someone cares about the distinction. I personally don't really do. And this should be fold map K, of course. Fold map K, long, short, can't type, circuit if monoid K of G combine K eval won't. If this all seems a little bit arcane to you, I think that's natural. Like any new code base will do that to you. But basically what this allows us to, if you have some kind of list or some kind of foldable structure and you want to implement short circuiting and you want to test that, you can just use these laws in your own tests and it will just work, which I think is pretty neat. So you have this law set, and now I assume in something like the list tests. So in cats we have an SBT module for all the laws, and we have another module for all the tests. So this is a different module. You guys all still there? I haven't seen any comment since Artur posted something at 20 minutes ago. I hope I haven't just been talking to myself, but that's how I usually do open source work, so I guess it wouldn't be too different from what I usually do. All right. So let's have a look at the list suite. And there should be some short circuit tests. Traverse filter. Here we'll just add the short circuit tests for fold map K, or foldable, I guess, foldable int. We're here still. Thank you, Zach. I appreciate it. All right, and now we can actually run this by going into tests JVM module, and I will try to only run this list suite. No, I didn't hear about your arbitrary K comment, Ross. Please, maybe I don't know what. Yeah, I'm new to this, so I really apologize for all of this, but yeah. Maybe send it again. Okay, Zach didn't see it either, so that, at least it's not completely my fault. All right, so we will run test only, and then the list suite. And this will probably compile for a while, so I am going to be right back. I'm just going to go to the bathroom real quick. All right, we are back, and seems we have some kind of. Oh, okay. Just missing an import, as far as I can tell. Okay, we're missing a bunch of stuff here. So we'll just start at the top. The type was inferred to be any. I guess. Of course. So this should be a function from A to option of B. So we'll just guess Scala cannot infer this, which makes sense. Wait, option of A. There we go. Don't have any B's here. Wonder if this should be sum of empty. We'll see, I guess. Let's recompile this. So do we see? Maybe cat's $5.99. I will open this if I can get this to work. Then we can have a look at it together. Also, by the way, for anyone that has any questions while all of this is going on, please don't be afraid at all to just put them in the comments. I'm very happy to answer anything. And yeah, it's weird that it rejects links. That doesn't really make a lot of sense to me. Okay, 7 errors. Did we have 6? We had 8 before, so that's good. Right, so just as I assumed right here, we will need to wrap this in the sum. Also, I guess we need to do something here. Option. Ooh. And this makes sense because, you know, this in the traverse case, we go from A to option of A. In this case, we just go from A to option of empty or none, and that option of nothing in that case. And the Scala compiler can't figure out what we actually want this function to result in. I wonder if Haskell could, though. Maybe Ross can tell us that. All right, so I think this should all resolve, but we have this thing right here. What is that? Oh, yeah, this is an f of A, but definitely shouldn't be an f of A. It should be an option of A. All right, let's try this again. Let's see what happens. Also, thank you for sending those selfies. I just saw that on Twitter. That was really nice. That's cool. What was it? 111 Scala sources. Yeah, this might take a while. Also, I think Matt commented on my quarantine hair, and yeah, it's gotten a bit out of hand. It's like, but yeah, that's what quarantine will do for you, I guess. I mean, it's only been 3 months. Wow, it feels like forever. All right, so we're still missing that import on short-circuiting tests. So we'll just import it right here. And then I think it should work now. It should at least run. La la la. Yeah, it's compiling 111 sources, which might take a while. Does anyone have something in CATS, some issue that they really want worked on, that has just been, I don't want to say ignored, because I don't think we ignore any issue. It's just like there's a lot, and sometimes they fall by the wayside. That's a good sign. It went from the 111 sources to 3. But yeah, like if there's something you really want me to work on, just put it up in the comments, and I'll see if I can get to it. Probably not today though. I think I'm gonna stop the stream in maybe like half an hour or something. I don't know. I feel like 2-hour stream is a long time. Does anyone really want to watch me wait for the compiler for 2 hours? I feel like a Dottie release, yeah. Dotty release would be nice. I think we're pretty much almost there for cats. The problem is that Scala Test, Scala Check hasn't been released for the latest or any of the Dotty milestones. I think at least nothing newer than 0.20 or something. And we're on 0.24 RC1 now, I believe. But also, like, it definitely, like, I know that someone published it not under like a different group ID, the Scala Test, Scala Check library, and with that, Cats as a project compiles fine under Dotty. It releases something I would love to see as well, but upstream dependencies are annoying. Maybe we should cut out Scala Test out of Cats, but or actually wait, this is something where right. This is something where Mike Pilquist told me we can reuse Scala Test, Scala Check, the 2.13 version, and just because Dotty has a compatibility layer, or compatibility layer is probably the wrong word, but it has some kind of compatibility where you can take libraries from older Scala versions and use them with Dotty. And I think, well, I went down this rabbit hole last week, but I forgot what was the result of that. I think, but yeah, Dotty release coming very soon. That's my promise or something. Yeah, I'll definitely work on it soon again. I don't know why. Yeah, I'm just gonna stop talking. It's compiling really slowly. I guess I can check out the thing that you mentioned, Ross. If you're still listening, Typelevel Cats, and it was like the issue 599. I guess, how do I even find that? I guess I can just do this. Yeah. Remove usage from laws-based test. Given that we only provide, okay, well, this isn't much to go on. C515 for discussion. Written before, so EQK was a thing at some point in Cats. That's interesting. 2015. Wow, we're really going into like the history of this thing. Okay, there's a lot of stuff here. So I have the same concerns, but I'm not able to mean that instance between EQ because decoder can't have an arbitrary K. Yeah, that makes a lot of sense actually. Yeah, it's a good point. I hadn't even thought about that. Yeah, good point. That makes a lot of sense to me. So were they I guess they were defined and heard the teacher calling. I guess they must have been defined in Cats. Yeah, that's interesting. It's good to know. All right, let's check back in. Oh, we have 6 errors. I somehow, wait, how did this should not be here. This is something I had from the other PR that basically adds variance. Wait, is this all the errors though? Variance suite. Okay, so this was just a thing. Oh, another 103 Scala sources have to be compiled. Yeah, this is also the life of like an open source maintainer. A lot of the times when you work on especially things that are, I don't want to say mind-numbingly dumb or like, but it's something where you basically don't have to really think about a lot coding. Like, you're just writing a lot of boilerplate, or just like, defining instances without thinking much about them. Then a lot of the time I'll just write something up, compile it, and then just watch TV by the side, which I guess would not make for a very entertaining stream, but it does help with getting over those compile times. All right. I guess we could look at some other instances for the fold map K optimization. So we could look at something like set. Let me look at set. Set's an interesting data type. Combine K. Oh yeah, that's cool too. Yeah, interesting. Where is fold? Oh, there's no fold map. Oh right, set doesn't even have a fold map K. I don't think there's an unordered fold map K, but maybe there should be. Now, I think I was the one that introduced these unordered things, and I'm not sure if they were worth it. But I mean, they make sense. It's just like a lot of people don't really care. But we can do the same for sorted set, which is actually a much nicer type. Just the order constraint annoys a lot of people, which is fair. So do we have fold map here somewhere? I guess there's fold. There's no fold map K though, so we will definitely just put it right here. And so wait, where's sorted set doesn't have a traverse instance because it's not a functor. Oh yeah, that's interesting too. Right. What's the best way to go through a sorted set? It's kind of like this, right? Hey, my roommate just came in. Yeah, it's also, you know, living in New York, gotta have a roommate. So we'll just try this. Override def full map K. And I guess the best way going through this thing is, I guess get uses an iterator. Maybe I should use an iterator. What's the best way to traverse a sorted set? Does anyone know? If they do, please let me know in the comments. I feel like a YouTuber now. Wow. like the whole answer in the comments, you know, it's like I guess it kind of rubs off on you. Okay, what? Oh, we have some deprecated stuff. Oh, and the tests. I guess that's not too bad. All right. I guess I'm just gonna go with an iterator, right? Oh, I have to do a tail recursively too. Yeah, that's interesting. I don't think I've written the tail rec annotation in a long time, so this will be fun. Wait, what? How does this even make sense? Goes the next iterator, and then. Yeah, okay. I don't think I've used iterators, or I've used tail recursion. I've never used both. This is interesting to me. I wonder if I just use the iterator, it should be stack safe though, right? Because why do I even need recursion here at all if I'm using an iterator? I guess this is just to be safe and not use a while loop. Oh, the results are coming in. That's cool. That's very cool. Looks all green. All right, awesome. So before we go on with this, I'm going to do the same thing with the vector tests and see if I got that one right too. So copy this and use the functor foldable. That's what it is. And I'm going to test this. Oh, let's see, test only. Oh yeah, well this obviously cannot work. Compilation times. I used to run pure bloop, including tests. SPT would just run in CI. Is there a reason that would not work for working with cats? I don't think there's a reason that wouldn't work. Oh yeah. I think that should work fine, to be honest. But I haven't gotten around to using pure bloop. Maybe I should. We all can't wait till bloop becomes the backend for SPT. Yeah, that's definitely very true. I feel like, wasn't that a thing? No, that was Metal's bloop integration that happened like a while ago, right? But doesn't SPT already integrate with bloop? All right, vector looks good too. Fuck yes. Oh, I said it again. Oops. Okay. So let's figure out this full map K for a sorted set. And I think I'm gonna... Do you guys want me to go with a tail recursive function, or do you guys just want me to take the iterator? Because I feel like the iterator already has state, so we're already doing like impure things, right? So it doesn't really... At that point, you know, it doesn't really... You're passing around a stateful thing. Yeah. There was a recent blog post from Chris Kipp explaining bloop. It helped clarify some of its purpose to me. I actually talked to oh god, what's his name? The bloop person. Fuck. I want to say. Oh, I'm so bad with names. He's such a great guy too. We talked for so long at Scala World. And yeah, like he told me all about bloop, and it all made sense to me. But I thought it already was. It already had an integration into SPT. So I'm not really sure what happened there. All right, so I'm just gonna go ahead and write this with an iterator. So it's, oh, I can't do this after the tail rec. So if I get the iterator, and what I want to do is basically call g.combine k-eval with you know, iter.next every time. I haven't thought it in this kind of I want to say mutable imperative style for a long time, so bear with me if I'm if I'm taking a while. So I want to call it with next. Obviously we want to call the f function on this, and we also want to do it. Oh, look, this is interesting. I guess I really need a while loop. Yeah, I haven't written a while loop in such a long time. SPT bloop install only generates metadata for bloop based on an SPT project. Oh, interesting. So if I do that, I need to still run bloop manually. Yeah. Well, I mean, I don't know. Compile times usually aren't much of an issue because there's always something else I can do in the meantime. Or at least, like, at work we have microservices, so compile times are really not an issue. So it only really affects my open source work, pretty much. But basically, what am I saying? Yeah, like compile times haven't mattered enough for me to actually go and install bloop. Basically, that's what I'm saying. The integration I mentioned is SPT using bloop to compile instead of running Scala C itself. Oh yeah. Yeah, that's what I figured. Metals runs bloop. Yeah, exactly. Metals runs bloop, and metals is super fast. But I thought, I guess they use the same like build cache kind of thing, where like the Ivy cache, the Corsair cache, which is now. But yeah, in any case, what do I need to do here? And I actually use bloop via metals. Oh, so I could just. Well, the metals import took like 10 minutes and it wasn't done. So I can't just rely on metals. But like, looks like most of the support here looks fine. Like, it seems to be fine. All right, so I'm going to have a while loop. It's going to be ugly as fuck. So I'm not going to do it. I'm going to go with the tail recursive, even though I said I wasn't. I am going to do it because I can't wrap my head around. Because then I would need like while, because you want to short circuit at some point, right? So I'm not even sure how I would do that. So I'm just gonna go with this. Oh, we don't care about the index. What we care about here is the iterator. Yeah, I'm just gonna write this out and see what happens, because really I'm not sure what I'm doing at all. I know we need this. We must need some kind of state here though. Right, we're passing some kind of state. How to do this for vector? I feel like this should be similar. I guess the int is the state. And I guess the iterator is the state. We'll just pass the new state of the iterator. That seems weird to me. But maybe that's just how it is. Okay, so so we need, of course, to do an if iter or it as next. I guess like the short circuiting is would be done without the while loop. So I guess we wouldn't, like the while loop would just be has next, right? Maybe not. No, definitely not. No. All right, I'm just gonna do it like this. If it has a next, we want to take the next thing and then call go with the iterator. And if it doesn't, we will just do a now of g.empty. And then we'll just call go with fa.iterator, get out the value of the eval, remove this line, and then add that to the sorted set suite. Should be here somewhere. Sorted set suite. Does it not have short circuiting yet? Am I just blind? Short. No. Okay. That's very interesting. I'm just gonna copy it from the vector suite. Maybe maybe this is just something we missed. And if anyone wants to add a short circuiting traverse, or like maybe it does short circuit but the tests just aren't there, or maybe it just doesn't short circuit. It's all very much in the realm of possibility. So a sort set of int sort set, and we'll try to run this. Oh, I might need to add this to the tests here. To the imports. Short circuiting tests. Yeah. And now we'll do test only. So it's set suite and see what happens. Doing a lot of stuff. If Oh yeah, that was dumb. I called it by the wrong name. But yeah, now that I look at it, it definitely contains, because this is not in tail recursive position. Damn, yeah, that's very true. So I guess I should just use a while loop. Should I? Because no. Huh. Okay, so this isn't tail recursive because of this part, which makes perfect sense to me. So I guess I need to do this a bit differently. I'm not sure how though. I think I'm gonna call it a day for today. I've been streaming for 1 hour and 40 minutes. I feel like that's, yeah, Ross said it's dinner time here. Yeah, exactly. I haven't had dinner either. So thanks everyone for tuning in. I see we have 14 people live right now. If you have any questions at all, like just, any questions about this or anything about something else too, just, message me on Twitter or like do anything like on Gitter, Twitter, doesn't really matter. You guys should probably know where to find me. Yeah, thanks so much for tuning in. And if you like this, and you want to see this again, I do sound like a YouTuber. But yeah, like if you like this and want to see this again, let me know, and I can probably do this like maybe once a week or something, maybe every 2 weeks. This has been fun for me. So yeah, thanks a lot, and bye. Yeah, no, I just need to end stream.